Right now, somewhere in the world, 1,000 people are walking toward each other on a crowded street, and almost nobody is colliding. Think about how strange that is. There's no traffic light, no lanes painted on the ground. No one is in charge. Every person has a different destination, a different speed, a different mood, and yet the whole thing flows like water around a stone. You do this every day without noticing, and it turns out you are following rules that nobody ever taught you and that nobody ever wrote down. Here is the first thing your brain is doing without asking you. Watch a busy sidewalk from above, and something remarkable appears. The crowd splits itself into lanes. People heading left drift into one stream. People heading right drift into another. Two rivers flowing past each other, sometimes 3 or 4 lanes deep. Nobody organized this. Nobody agreed to it. There is no sign, no rule, no leader. The lanes just appear, and they appear in seconds. Scientists call this lane formation, and it is one of the purest examples of order emerging out of nothing. So why does it happen? The answer is beautifully lazy. Walking straight into someone coming the other way is expensive. You have to slow down, swerve, and negotiate. But walking behind someone going your direction is cheap. They clear the path, they break the wind, they tell you where the gaps are. So every single person, purely out of self-interest, drifts toward people moving the same way they are. Nobody is thinking about lanes. Everyone is just avoiding effort. And out of 1,000 selfish little decisions, a beautiful pattern appears. This has a name: self-organization. It means a global pattern arising from purely local rules, with no plan and no planner. Birds do it when they flock, fish do it when they school, and you do it every time you walk into a train station. In 1995, a physicist named Dirk Helbing wrote down the math. He treated each pedestrian like a particle, pushed by invisible forces. A force pulling you toward your destination. A force pushing you away from other people. A force pushing you away from walls. That is basically it. 3 simple rules. Feed those 3 rules into a computer with a few hundred simulated people and watch what happens. Within moments, the simulated crowd forms lanes. All by itself. Nobody programmed lanes. Nobody told the particles to cooperate. The lanes are not in the rules. They emerge from the rules. And that is the whole magic trick of self-organization. The pattern is not written anywhere. It lives in the interaction, not in the individuals. Take any one person out and study them, and you would never find a lane inside them. It gets stranger. Take 2 crowds and make them cross each other at an angle like an X. What should happen is chaos. What actually happens is that the crowd forms diagonal stripes. Bands of people from one flow slide neatly between bands from the other, like the teeth of 2 combs sliding together. Nobody plans the stripes either. They are just the cheapest way for 2 rivers to pass through one another. And once you know they are there, you can stand on a balcony above a busy square and watch them forming and dissolving all day long. But here is where the particle idea starts to break down. Because you are not a billiard ball. When you walk towards someone, you do not react to where they are. You react to where they are going to be. Your brain runs a tiny simulation of the next few seconds. For every person near you, all at once, you watch their shoulders, you watch their eyes, you watch the angle of their feet, and you steer for the gap that will exist, not the gap that exists now. Scientists call this mutual anticipation, and it is doing a lot more work than anyone realized. In 2021, a team of researchers proved it with a beautifully simple experiment. They had volunteers walk toward each other in a corridor, and the lanes formed as usual. Then they changed one thing. They handed a few of the walkers a phone and asked them to do simple math problems while walking. Just a handful of distracted people out of the whole crowd, and the lanes fell apart. Near collisions shot up, not only for the distracted people, for everyone. The people behind them slowed down. The order dissolved. Read that again because it is the most important sentence in this video. Walking is not something you do alone next to other people. Walking through a crowd is a cooperative act. Every time you sidestep a stranger, the 2 of you just negotiated silently in about half a second without a single word. Both of you gave a little. Both of you predicted the other. And when someone stops predicting because they are looking at a screen, the entire negotiation collapses for everyone downstream of them. Now, if you want to feel humble, look at ants. Army ants build living highways between their nest and their food, and those highways carry enormous traffic without ever jamming. Researchers found that the ants organize into 3 lanes. The ants going out to hunt take the 2 outer lanes. The ants carrying food home take the middle lane, protecting the cargo and keeping the flow smooth. And unlike human traffic, ant traffic almost never grinds to a halt. Even at extreme densities, they just keep flowing. So why are ants better at this than we are? Because ants do not have opinions. An ant has no destination it desperately wants to reach. It does not check its phone. It does not decide to stop suddenly to look at a shop window. It follows a chemical trail and a few tiny rules. And that is all. Human crowds carry something ants never do. We carry goals. And goals, competing goals, pulling in different directions, are exactly what turns a smooth flow into a dangerous one, which brings us to doors. A doorway is where crowd physics gets serious, because a doorway is a bottleneck. Watch people file through a normal door, and you will see something odd. The flow does not share nicely, it oscillates. A clump of people from one side pours through, then the pressure flips, and a clump from the other side pours back. Push, pause, push, pause. When it works, we call it the zipper. 2 streams merging perfectly, one from each side, like teeth closing. But now imagine, everyone is in a hurry. Maybe there is a fire. Maybe the concert just ended. Everyone pushes harder, moves faster, tries to squeeze through first. And here is the cruelest fact in this entire field. The harder everyone pushes, the fewer people get through. It is called the faster is slower effect. And it is not a theory. It has been measured in real experiments with real humans, and it happens to sheep escaping a barn, and even to grains of sand pouring through a funnel. The reason is something called arching. Under pressure, the people right at the doorway lock together into a curved arch, exactly like stones in a stone bridge. Every person is pressed against their neighbors, and the arch holds itself up. The harder you push from behind, the stronger the arch gets. The flow stops. Then the arch collapses. A clump squirts through, and a new arch forms. It is a doorway that keeps clogging itself, and everybody pushing is what builds the clog. Now for the fix. And it is deeply counterintuitive. If you want more people to get out of a door in an emergency, you can put an obstacle in front of it, a pillar, placed just off to one side of the exit. It sounds insane. You are making the opening smaller, but the pillar breaks up the arch before it can form. It splits the pressure. It stops the crowd from locking together. And in the right position, a well-placed obstacle can actually let more people through, not fewer. So far, this has been charming. Lanes, stripes, ants, zippers. Now let us talk about what happens when a crowd gets too dense, because this is where the physics turns lethal. Everything depends on one number. How many people are standing in a single square meter? At 1 or 2 people per square meter, you walk freely. You choose your path. At 4, you can still move, but you can no longer choose. You go where the crowd goes. And somewhere above 5 or 6 people per square meter, something terrible happens. You stop being a person and start being a fluid. At that density, you are no longer walking. You are being carried. The gaps between bodies disappear, and forces stop being local. Push one person on the edge, and that push travels through the crowd like a wave through water. Researchers watching video of these crowds saw shockwaves rolling through them. First, stop and go waves, where the whole mass surges forward and then freezes over and over. That is the warning sign. That is the crowd telling you it has stopped being a group of people. And then comes the thing with the terrible name, crowd turbulence. Above a critical density, the pushing stops being organized at all. People are shoved sideways, backwards, in random directions, dozens of times a minute. Helbing and his colleagues found this by analyzing video from a real disaster at the Hajj pilgrimage in 2006. The crowd stopped flowing and started churning, exactly like a boiling liquid. And in that churn, people are lifted off their feet, spun, and pressed together with forces strong enough to bend steel barriers. Now I need to correct something you have probably believed your entire life. When people die in a crowd, the newspapers say stampede. They say panic. They say the crowd trampled people. That is almost always wrong. In the great majority of these disasters, nobody is running. Nobody is trampling. The victims are standing upright, packed so tightly they cannot expand their chest to breathe. It is called compressive asphyxia. People die on their feet in silence, surrounded by people who are trying to help them. This matters more than you might think, because if you believe a crowd disaster was caused by panicking, selfish people, then you blame the crowd. And for decades, that is exactly what happened. Families were told their relatives died because the crowd was a mob, but the research says the opposite. Under extreme stress, crowds are overwhelmingly cooperative. People hold each other up. Strangers pull strangers out. The failure is almost never the people. It is the geometry. It is a badly designed exit, a tunnel that narrows, a gate that stayed shut. Crowds do one more thing that nobody expected, and it nearly broke a bridge. In the year 2000, London opened the Millennium Bridge. On the first day, thousands of people walked across, and the bridge began to sway sideways. Here is the loop that did it. A tiny sway makes you widen your stance to keep your balance. Widening your stance pushes the bridge sideways, and crucially, it makes you step in time with the sway. So more people sync up, which makes the sway bigger, which syncs up more people. Nobody told those people to walk in step. They did not want to. The bridge itself taught them in seconds through their own feet. They were an orchestra with no conductor, playing a song none of them chose. The bridge was closed after 2 days, and it took nearly 2 years and dozens of dampers to fix. And it remains the single most beautiful demonstration that a crowd is not a pile of individuals. A crowd is a system, and systems have behavior that no member of them intended. So where does all of this leave you? Every model we have starts by treating you like a particle, and the models work astonishingly well. They predict the lanes, they predict the stripes, they predict the clogs and the waves. Engineers now use them to design train stations, stadiums, and pilgrimage routes. After that disaster in 2006, the whole site was redesigned using this science, with one-way flows and reshaped bridges. The physics of crowds has genuinely saved lives, and yet you are not a particle. Particles do not anticipate. Particles do not look at a stranger's shoulders and guess where they will be in 2 seconds. Particles do not cooperate. That phone experiment proved the difference. The moment you stop anticipating, you stop being the thing the model is describing, and the beautiful pattern falls apart around you. Your intelligence is not decoration on top of the physics. It is part of the physics. There is one more idea hiding in here, and it is bigger than crowds. Nobody in that crowd knows the pattern exists. The lanes are invisible from inside them. You have walked in a lane thousands of times and never once seen it. To see the pattern, you have to leave the crowd and climb to the balcony, which raises an uncomfortable question. How many other patterns are you inside of right now, moving in formation with millions of other people, unable to see the shape you are making? So let us put the whole thing back together. Every person in a crowd follows a few simple, selfish, local rules. Get to my goal. Do not touch anyone. Do not hit the wall. From those rules alone, lanes appear, stripes appear, zippers appear. Layer on human anticipation, and the whole thing gets smoother until somebody looks at their phone. Squeeze the same crowd too tightly, and the rules stop working. The individuals dissolve. The crowd becomes a fluid, and then it boils. So tomorrow, when you step out onto a busy street, try something. Do not look ahead. Look down and slightly to the side. Notice which way the people beside you are walking. I promise you, they are going the same way you are. You are inside a lane. You did not choose it, you did not agree to it, and you did not even notice it. Nobody is in charge, and yet the whole thing works. And now, at least, you can see it. Thanks for watching.